This is my geometry course. Today we're going to continue to learn special quadrilaterals. In the previous class we learned parallelograms, but today we're going to go over kites, rhombi, trapezoids, rectangles, and squares. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. I want you to start by taking screenshots of these first two pages. You can see on the left we have the definitions of the quadrilaterals we're going to learn today. And so rectangles and squares you probably already know, but the technical definition is a quadrilateral with all angles are right angles. Now with a square you have a slightly more detailed definition. You have all right angles except all the sides have to be congruent also. So again, all those red angles there, those are all right angles. But we're going to learn something new today. We're going to learn rhombi. That's the plural of rhombus. You can also say rhombuses. It doesn't really matter. But you can see that we have a rhombus here, and a square is also a rhombus. But not every rhombus is a square, because this is certainly not a square. So a rhombus, again, is just a quadrilateral whose sides are all congruent. We're also going to learn kites. That's what you would fly with a string. But the shape is also called a kite. And that's a quadrilateral with exactly two pairs of congruent consecutive sides. So you have consecutive, meaning they're next to each other, and they're congruent. So those are two congruent sides, and these are two congruent sides. But you can't have sides that are opposite that are congruent, because then it wouldn't be a kite. Now, there's also trapezoids. That's a quadrilateral with one pair of parallel sides. Those parallel sides are called bases, and the other sides are called legs. And these two angles, because they're touching this bottom base, those would be the base angles for this base, which I called base 1. And these two angles would be the angles for base 2. So those are the base angles for base 2. And I color-coded that, or color-coordinated it. And it doesn't really matter which side you call base 1 or base 2 or leg 1 or leg 2. Now this is an isosceles. There's a special type of trapezoid called an isosceles trapezoid. That's a trapezoid where all the legs the two legs are congruent. Not all sides, but the two legs are congruent. And now I mentioned that some of these definitions kind of overlap. A square is a rhombus. So this Venn diagram shows the overlap. It's important to understand that rhombi, squares, and rectangles are all parallelograms. And squares are rhombuses, but and squares are also rectangles, but it's important to understand that rectangles are not rhombi. So this Venn diagram might help you. And so let's go on. We're going to start with rhombi, and we'll do the other quadrilaterals later on. Let's talk about our first theorem. So the first theorem just says that the diagonals of a rhombus are perpendicular. So that's a 90-degree angle there. It's a simple theorem. I want you to get a screenshot of these theorems here. These are the second, third, and fourth theorems we're going to learn. So this theorem says that if you draw the diagonals, the angles, the inner angles, all the inner angles in a rhombus are bisected. So that means that these two angles are congruent, these two angles are congruent, these two angles are congruent, and so on and so forth. All those inner angles are bisected by the diagonals. Now we're going to actually find out that it turns out that these angles are all congruent to these angles, and these angles are all congruent to these angles. I didn't show that in this picture, but we're gonna discover that. And the reason for that is that all rhombi are parallelograms. That's what this theorem says, that any rhombus is a parallelogram. And then also we have the rhombus right triangles theorem that says that if you draw the diagonals in a rhombus, then four congruent triangles are created, and all those triangles are right triangles. So you have this one, you have this one, you have this one. They're all right triangles, and they're all congruent. And that's kind of helpful because it's gonna help you to see what's going on with these rhombi. So let's do some practice problems. Again, you should have screenshots of all that stuff. So be sure to get a screenshot of this page. If you don't have these definitions, then you're really not going to be able to do any of these practice problems. Also a screenshot of this page. So we're told that these are rhombi. So what that means is that all the sides are congruent. So we know that 5x plus 1 is equal to x plus 9. And so we can subtract x from both sides, subtract 1 from both sides, divide both sides by 4, and we get x is equal to 2. And now we want to find y. So y, we can just plug in 2 to one of those expressions. It doesn't matter which one. And we get 11. So we know y is equal to 11. And we know that z must also be equal to 11 because z is just one of those sides. They're all the sides in a rhombus are congruent. And what else can we do? So now we're on to the angles. Now remember, the diagonals bisect all the angles. So this angle is bisected by that diagonal, which means that theta is 70 degrees. So very simple. Theta is 70 degrees. And now we just have to find omega. Now listen to this. This is very important. Remember, we mentioned that all rhombi are parallelograms. So this is a parallelogram. That means, and I'm going to show you the theorems for parallelograms. And if that's too small for you, then you can go back to the previous class where we talk about where we show the theorems for parallelograms. So what that means is that all those theorems they apply. So we know that opposite angles are congruent. So if whatever this angle has to be the same. So 70 plus 70 is 140, so this is 140. But we also learned from the theorems we learned today that these angles are both bisected. So what that means is that theta is 70, and this angle is 70, and this angle is 70, and so on and so forth. So we know that this angle is 70. Again, that's kind of complicated, I guess, but this angle is the same as this angle. We know this angle is 140, so that means this angle is 140. But we also know that this angle is bisected by the diagonal. So 140 divided by 2 is 70, so that's why I know that this is 70. So hopefully you followed all that, because it's kind of hard to write stuff that's going to explain that. Plus it would take forever. So now we can use the triangle sum theorem. So we know omega plus 70 is equal to 180. All the angles in a triangle add up to 180. So we're just using this left triangle over here. So omega plus 140 is equal to 180. Subtract 140 from both sides, and we get omega is equal to 40 degrees. And, whoops, I forgot to rectangle that. So that's number 1. Let's do a couple more of these before you try one on your own. So this is a rhombus. That means that all sides are congruent. So we know that those sides must be equal. Y is equal to 3 with just basic algebra. And that means that z is equal to, we can just take one of those sides. I'll take 10y, but I'll plug in what we found for y. Z is 30. Because we know that z must be the length of each side. And we know 10y is a side, so we just plugged in 3. And so now we know x must be 30 also, because x is just another side. Again, these are rhombi, so all the sides are congruent. And what else can we find out? Now alpha, that's really easy because that was our first theorem. The diagonals in a rhombus are perpendicular, so alpha must be 90 degrees. Do you see why that is? because those diagonals, those orange diagonals, are perpendicular. That's a theorem. And so remember, we also have the theorem that there's 4 right triangles that are created, and they're all congruent. So, and what we know that these angles are all 90. So obviously this angle is 90, and we can use a triangle sum theorem to find beta. So I'm going to take that triangle out and put it down here, just so you know exactly what we're doing. So we have that right triangle there, and we have 40 degrees. And we have 90 degrees, and then we have beta. And so 40 plus beta plus 90 is equal to 180. Again, that's the triangle sum theorem. If you're having trouble remembering the triangle sum theorem, then that's a huge problem. That means you're not doing the homework. So add 40 and 90, and we get 130. Subtract 130 from both sides, and we get 50 degrees. Beta is equal to 50 degrees. All right, let's try one more of these before you try one on your own. Now, rhombi are parallelograms. Again, I'll put those theorems up on the page for you, just in case you didn't get them the first time. And again, you can go back to the previous class, or whatever class we covered parallelograms. And because a rhombus is a parallelogram, that means that diagonals bisect each other. That's one of the theorems that we learned about parallelograms. So that means that y plus 6 is equal to 2y plus 3. Just do the algebra on that, and we get y is equal to 3. Now, omega, that is equal to 90 degrees because we learned that first theorem. That was our first theorem of the day, that diagonals of a rhombi are perpendicular. And let's see here. So if you followed the logic before, you know that theta is 60. Because this angle is bisected, this angle is bisected, and those two angles are congruent, so theta must be 60. Some students might have a little trouble seeing that, but again, if you follow the logic we used last time, it's the same situation. Okay, so now it's time for you to try. So again, if you didn't get a screenshot of these, I hate to keep turning back to this, but get a screenshot of those, get a screenshot of these pages, and you're going to need those in order to do these problems. If you don't have those theorems, and if you don't have a few practice problems to look at, then you might struggle with this. But go ahead and try number 4. Remember, these are rhombi, and you're looking for all these variables. All the sides are congruent. And go ahead and attempt number 4. When you come back, we'll do it together. All right, we're back. So the sides are congruent, so I know that those sides must be equal to each other. And now I'm going to add 3z to both sides, subtract 13 from both sides, and we get z is equal to 1. And now we're going to find y. Y is equal to, I can just use any one of those. I'll use -3 and then plug in 1 for z. And so we get 17. So y is 17. And x must also be 17 because all the sides are congruent. And remember, we have a theorem that says that the diagonals in any rhombus bisect the angles. So theta, or if that angle up there, that pink angle, is 58 degrees, then alpha must be 58 degrees also. Again, this is not hard if you have the theorems in front of you. If you don't have the theorems in front of you, then you're not going to have a clue what you're doing. Let's see. So if you didn't get those theorems, if you didn't get a screenshot, that's okay. Just go back and get that screenshot, or else you're going to fall behind pretty quickly. So now we just have to find omega. And again, we're going to use the same logic here. This might be the part where students have a little trouble. So we know that's 58 and 58. And that angle is congruent to this angle because opposite angles in parallelograms are congruent. So you can see that 58 plus 58 is 116. So this angle must be 116. And actually, I'm sorry, we can just use this triangle. So this angle is 58 and this angle is 58. So we can just use the triangle sum theorem. Omega plus 58 plus another 58 is equal to 180. And then we just add those up, you get 116. And then we get, looks like it's going to be 64 degrees for omega. All right, so if you got those answers, good job. We should have 1, 2, 3, 4, 5 variables. It looks like we got it. All right, I'm going to leave those in the window, and I want you to go ahead and try number 5. And when you come back, we'll do it together. All right, we're back. First of all, probably an easy place to start is omega. Omega is 90 degrees because the diagonals are perpendicular. And secondly, we're going to set the sides equal and just solve that equation. X is equal to 4. Whoops, I forgot to rectangle that. And obviously y, we just have to use one of those, plug in 4 for x, and we get 22. And if y is 22, then z has to be 22 also. And let's see, now we just have to find theta. But again, theta is just going to be 44 degrees. Because the angles are bisected and they're the same angle. So if you got 44 degrees on the opposite side bisected by the diagonal, and you got 44 on the original side. Whoops, I forgot to write y. I got a rectangle y. Y is 22. So if you got those answers, good job. Go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. I'm going to start with an easy one. Theta is obviously just 35 because that angle is bisected. And omega is just going to be 35 again because it's the opposite side that's bisected by the same angle, or the same angle is bisected by the diagonal. And then step 3, this is a parallelogram, so we know that diagonals bisect each other. So 4x is equal to 2x plus 6, and do the algebra on that. Subtract 2x from both sides, divide by 2, x is equal to 3, and there you go. So if you got those answers, good job. So now we're going to do a couple more rhombi problems, but before we do those, we have to take a screenshot of this review material. We need the Pythagorean theorem, and we need the special triangle theorems. So I'm going to do this first one. Now, rhombi are divided up into 4 congruent right triangles. Remember, we learned that. That was our last theorem for rhombi, this theorem here. So we have 4 right triangles, and I'm going to pull one of those triangles out. so you can see what's going on. And this side is 12, and this side is 5, and this side is x. So we have to find x first. And to do that, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. That's the theorem over here. This theorem up here. So again, we learned that in a previous class. So we have 12 squared plus 5 squared equals x squared. And we have 144 plus 25. You can use a calculator for 12 squared if you need to. Add them together, you get 169 is equal to x squared. And so we found x squared. We don't want x squared. We want x. So you have to get rid of the power by square rooting both sides, because square root is the opposite of squaring. So that gets rid of the power on the x, and then remember, this is asking what number times itself is 169. So you can use your calculator for that if you don't remember exactly what that is, because that's not an easy calculation. But it's going to be 13. And remember, a length can never be negative, so we just write positive. So x is equal to 13. So now we can find P and L. So just to save room, I guess I'll just keep going down for now. P is equal to 13. Do you see why? Because all the sides are congruent, because this is a rhombus. And L is also equal to 13. All the sides are congruent, all the outside sides. And so another easy thing is omega. Obviously that's going to be 90 degrees. And what else can we do? Now this is a parallelogram, so diagonals are bisected. So if this side is 12, or this length is 12, then this length must be 12 also. So y is equal to 12. It'd be nice to actually explain, how we know this, but if you did that, these problems would be really long. It would take forever to get them done, so I'm not going to make you do that. And I don't want to do that either. And finally, if this side is 5, then z must be 5 also. I'm sorry my z looks like an n, but it's at a slant. Z is equal to 5 because that diagonal is bisected by the other diagonal. And I think that's it for that problem. So the difference with that problem is we were, we had to use the Pythagorean theorem. We didn't use special triangles yet. We use those on the other ones. But go ahead and try number 8. I'm going to leave all this in the window. You're going to have to use the Pythagorean theorem. And this problem is a little different because you're first going to have to show that this segment here is 15. Why? Because the diagonals bisect each other. That's a principle of a parallelogram. So go ahead and try number 8. And I gave you a little clue there because you're going to have to use the Pythagorean theorem probably in the first step. Theta is an easy one. I gave you an easy one. You should be able to figure that out in about 2 seconds. But go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. So theta is 90 degrees because of the first theorem that we learned. Diagonals in a rhombus are perpendicular. And let's see here. M has to be 15. Because that diagonal is bisected. This diagonal is bisected, so M has to be the same length as this segment. So now I'm going to pull out this triangle here, which we know is 90, because again, all these angles here are 90 degrees. And we know that one side is 17 and this side is 15. Whoops, I'm sorry, I put 15 degrees. Sorry about that. M is 15. So now we just have to find y. So as you can imagine, we're going to use the Pythagorean theorem. So I can put that over here, I guess. So a 15 squared plus plug in y, and then 17 squared. 17 squared is 289. You can use a calculator for that if you want to. 15 squared is 225, and you can use a calculator for that if you want to. Subtract 225 and you get 64. Y squared is equal to 64. So we found y squared. We don't want y squared. We want y. So you have to get rid of that square by doing the opposite of squaring, which is square rooting. So y is equal to plus or minus what number times itself is 64? Well, if you know your multiplication, if you know your products, then you know that it is 8. 8 times 8 is 64. But remember, a length cannot be negative, so we have to put positive 8. And so there we go, we have y. So now on to step 4. What else do we have here? We have x, but remember this diagonal is bisected by the other diagonal. So if we know y is 8, that means x has to be 8 also. And I forgot to find L. L's really easy because we know one side is 17. L would also be 17. Should have done that on one of the first steps because that was pretty easy. And I think that's about it. Yeah, it's about 5 things we needed to find. So if you got those answers, good job. So now we're going to do 2 more rhombus problems. You're going to need this information here, so be sure to get a screenshot of these theorems. Because remember, we learned special triangles and special angles in those triangles. We're going to need that for these problems. So what we're going to do, we'll do the first one together. Then you can do this one on your own. But I'm going to take out that upper left triangle. So we have 60 degrees, we have y, and we know this is a 90-degree angle because, again, diagonals bisect each other. Or excuse me, diagonals are perpendicular. So we can use the triangle sum theorem to find that this angle is 30 degrees because they have to all add up to 180. So we know that we have a special triangle. It's a 30, 60, 90 triangle. And I'm going to draw that better. $60, 30, 90 triangle. Now we also know that this diagonal is bisected. So if this length is 7, this length must be 7 also. These are just like puzzles. You have to solve the puzzle. Now the difference here is that we don't have any other sides. So a lot of times students would just stop and say, well, I can't do this. I can't use the Pythagorean theorem because I don't have any other sides. But if you have a special triangle, you know the relation between the sides just by looking at it. Because we have w root 3, that's the variable I used. You don't have to use w, but just make sure it's not a variable that's already on the problem. And so we can use that relation. Again, I just got that from the screenshot over here. I'm just using w because that's what I use for the theorem. And we have 60 degrees, 30, 90. And so that means that w is 7. So that means that the other side, the side opposite 60, that should be 7 root 3. And y should be 2 times 7. So y is going to be 14. All right, so y is 2 times 7, which is 14. So y is 14. So we found y. Now, we know we have this side. We found this side is 7 root 3. 7 root 3 there. So that means that this side must be 7 root 3 too, because the diagonals are bisect each other. So, forgot to write step 2 there. Actually, that was step 1. So step 2, x must be equal to 7 root 3. And let's see here, what else do we need to find? Now, all these triangles are congruent. So we know that this angle here must be 60, because this is the bigger one. So alpha must be 30. Because again, all the angles are the same. So if we know all the triangles are the same, so we know if one triangle is 30, 60, 90, then all of them must be 30, 60, 90. So this angle is the smaller one, so that must be 30. Sorry, I don't know why this thing is jumping around. The software just does weird things, like that window that just came up. I don't know why that keeps coming up. All right, so theta is 30 degrees. A lot of different ways to find alpha and theta in this problem. And I think that's it. 1, 2, 3, 4. 1, 2, 3, 4, right? All right, so why don't you go ahead and try number 10. Now you have to understand, you have to use these relations, or else you're not going to be able to solve the problem. So I'm going to leave number 9 in the window. Go ahead and try number 10. And when you come back, we'll do it together. All right, we're back. So I'm going to take the lower left triangle out. And this side is 10. Now this angle is bisected, again, just based on our theorems. You have to know those theorems. So that means that this angle must be 32. And 30, not 32. And then that angle is 90, right? Because the diagonals are perpendicular. And this angle, that must be obviously 60 by the triangle sum theorem. Now, if I draw that relation, remember that relation tells us that if the side opposite 30 is W, then the side opposite 60 is W root 3, and the hypotenuse is 2 times W. So we know that this side here, that's 10, and you may have struggled a little bit with this, because this is a little bit different than the previous problem, but this side must be 2 times the side opposite 30. So that means that this side must be 5. And obviously this side is whatever the side opposite 30 times root 3. Let me move that over a little bit. So that's 5 root 3. And based on this information, we're going to find everything else. So now this diagonal is bisected by the other diagonal. So if this length that we just found is 5, then x must be also 5. So x is 5. That's the first one we found. And we know that this length here is 5 root 3, so this length must be 5 root 3. So y is 5 root 3. And this angle is 30, so this angle must be 30. Again, I don't want to launch into a huge explanation of why that is, but you should be getting the hang of, or getting familiar with what these angles are. And again, these are all 30, 60, 90, so obviously this is the smaller of the angle. Every triangle is a 30, 60, 90. This angle is obviously the bigger of the two, so that would be, theta would be 60 degrees. So 1, 2, 3, 4 variables. Just want to make sure I didn't miss any. So if you got those answers, good. If you didn't, that's okay. Just go back and figure out what you did wrong. If you're struggling with these, it might be because you don't have those theorems in front of you. You have to have the theorems in front of you. because we just learned them, unless you have a photographic memory. All right, so now we're going, we learned rhombuses, or rhombi, and now we're going to learn kites. So I want you to go ahead and take a screenshot of these theorems. The first theorem we're going to learn says that the diagonals are perpendicular. So just like the diagonals were perpendicular for rhombi, they're perpendicular for kites too. Second theorem says that these two angles are congruent. Those are the angles that are between non-congruent sides. The third theorem says that this diagonal, if you draw a diagonal from the angles with vertices, if you draw a diagonal through the vertices of the angles that are between congruent sides, then that diagonal bisects the inner angles. So that's just another theorem. Go ahead and take a screenshot of all these theorems here. And I'm not going to keep turning back because I don't want to annoy students by doing that, so be sure to get a screenshot of these. Kite diagonal bisector theorem. So this means that this diagonal here bisects this diagonal. Okay, now it's extremely important to understand that this diagonal is not bisected. You can see that just by looking at it. But this diagonal is bisected, so that means that this length is equal to this length. But again, only one diagonal is bisected. And then the last theorem we're going to learn for kites says that if you draw the diagonals in a kite, 4 triangles are created. They're all right triangles because our first theorem said that the diagonals are perpendicular. And the green triangles are both congruent, and the blue triangles are both congruent. And, you know, you might think, well, why do we care about that? Well, because that's going to make it a lot easier for us to remember the theorems. Because we can see just by looking at these 4 triangles what sides are congruent, what sides are not. So you don't have to remember this theorem, but I would suggest it because it's going to help you remember how to do kite problems. So now we're going to do some practice problems. And again, if you didn't get screenshots of those, go back and do that. So we're told that this is a kite. If we know it's a kite, then we know that this side must be congruent to this side. That's just the definition of a kite. And also, this side must be congruent to this side. So by definition, we know that 2a plus 5 must be equal to 3a minus 2. Do the math on that, and we get a is equal to 7. Now, let's see here. We have that theorem that says that these two angles are congruent. So x is equal to 80. And you can just see by looking that those are going to be the congruent angles. Because a lot of students would say, well, how do I remember which ones are congruent? Well, you can just see by looking at it. Obviously, 45 is not congruent to omega. Omega is much bigger. It's got to be these two. But if you want a technical explanation, that's in the theorem. Let's see here. So now we have to find omega. And to do that, we're going to use the principle that the sum of all the angles in a quadrilateral is always 360. So 45 plus 80 plus x, which we just found is 80, plus omega must be 360 degrees. So add those up, we get 125. And I'm just going to add x also, so that would be 160, that would be 205 plus omega is equal to 360. And subtract 205 from both sides, and we get 155 degrees. So omega is 155 degrees. So again, these problems are not difficult, but you do have to look at the theorems and start to get familiar with them and remember them. You're going to be expected to remember these theorems. And I know that's very intimidating, but just get used to it. Sometimes you have to remember things in academic classes. So number 12, we know that these two sides are congruent because that's just the definition of a kite. So 20 is equal to x plus 5, x is equal to 15. And step 2, we have that theorem that tells us that this angle is bisected. So that means if this angle here is theta, this angle must also be theta. And I'm going to go ahead and pull out that lower left triangle. So we have 57, and this is going to be theta. And this is 90 because the diagonals bisect each other. So now we can just use the triangle sum theorem. 57 plus theta plus 90 is equal to 180. And 57 plus 90 is 147. And 180 minus 147 is 33. And let's see, what else do we need? I guess that's it, just two variables for that one. So let's try one more of these problems before you try one on your own. Now remember, one of those theorems tells us that the diagonals, this diagonal here bisects the other diagonal. So that means that y plus 6 is equal to 20. Subtract 6 from both sides, and we get 14. So y is 14, and we know that we have that theorem that tells us that these angles are bisected, so beta must be 15 degrees. Really no explanation needed for that one. And so we know that this angle here is 90 because diagonals are perpendicular in a kite. So we can use this angle, 55, we can use that angle to find this angle. And I guess I can just take that triangle out so you can see exactly what's going on here. That's kind of not a good right triangle. So we have 55 and we have alpha. It's not labeled as alpha, but we know it's alpha. So 55 plus alpha plus 90 must equal 180. Add that up and we get 145 plus alpha is equal to 180. Subtract 145 from both sides and we get 35. Alpha is equal to 35 degrees. And if alpha is 35, then we can use the triangle sum theorem again to find theta. But we don't really need to because we can see it's pretty obvious it's going to be 55. So theta is 55 degrees. There's a lot of symmetry in kites. So 1, 2, 3, 4. We should have found 4 answers there, and we got them. All right, so now it's time for you to try a kite problem. So I'm going to give you one more chance to take screenshots. I know I said I wasn't going to go back to these, but I just want to keep telling you over and over again, it's so important to have these theorems in front of you, or else you're going to go nowhere in this class, or in any other class really in this course. So now I'm going to leave these problems in the window, and why don't you try number 14, and when you come back we'll do it together. All right, we're back. So step 1, x is obviously 50, and we can write the units because there's no operations on x. And step 2, we know that this angle is bisected. That's one of the theorems. So theta is equal to 61 degrees. And we know that this angle must be 25. So I'm going to take the upper right triangle out. This is 25 and this is 90 because the diagonals bisect. And so we're looking for omega. And again, we just use the triangle sum theorem. So omega plus 25 plus 90 must be 180. Add 90 and 25 and we get 115. Subtract 115 and we get 65 degrees. So omega is 65. And 1, 2, 3 variables we're looking for, so that looks like that's it. So if you got that answer, good job. All right, on to number 15. So go ahead and try number 15, and when you come back, we'll do it together. All right, we're back. Let's see here. We know that these sides must be congruent. So x plus 4 must be equal to 5x minus 4. Do the algebra on that. We get 4x is equal to 8. X is equal to 2. And opposite, these angles are congruent, but we don't know what they are. So we're going to have to use the principle that the sum of the angles is equal to 360. So omega plus theta plus 90 plus 70 is equal to 360. And we do know that omega and theta are equal. But anyway, we'll get to that later on. So 160, you add those up. Omega plus theta. Subtract 160 from both sides, we get 200 is equal to the sum of omega and theta. But omega and theta are the same. I just want to make sure that you see that. So that means that you just divide by 2 and you get 100 degrees, and theta is 100 degrees. So if you got those answers, good job. So why don't you go ahead and try number 16. And remember, this diagonal is bisected. So try number 16, and when you come back, we'll do it together. All right, we're back. Well, let's start with an easy one. Omega has to be 30 degrees because that's one of our theorems. It says that these angles are bisected, not the other angles. By the way, if you think these angles are bisected, that's not correct. These angles are congruent, but they're not bisected. So there's a lot of information here, I know. Now, what else can we do here? I'm going to go ahead and set those segments equal because, again, that diagonal is bisected by the other diagonal. Add 2x to both sides, we get 5x. Subtract 1 from both sides, divide both sides by 5, and x is equal to 3. So we found x. Let's see here. So alpha, I'll find alpha next. We can use the triangle sum theorem. Let me show you the triangle that we're using. So we have 51 and 90 and alpha. And I'm sorry I'm not drawing those triangles bigger. I probably should be doing that. Just don't want to take up too much room. So 51 alpha. So alpha plus 51 plus 90 is equal to 180. 90 plus 51 is 141. And subtract 141 from both sides, and we get alpha is equal to 39 degrees. Let's see here. So now we know that these two triangles are the same triangles. So that means that beta must be 51. And theta must be 39 degrees. So we should have 1, 2, 3, 4, 5 variables. 1, 2, 3, 4, 5. So if you got those answers, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, so now we're ready to go on to some more of these special triangle problems. Now again, if you didn't get screenshots of these special triangle theorems, go ahead and do that now, because you're going to need these. I'm going to do 17. First of all, L, that's really easy. That should just be 17, right? So that was easy. Let's see. So I'm going to take the upper right triangle. I'm going to redraw it. And we have M. And we're told that this side is 8 root 3. And so we know that this angle up here is 30, right? And we know that this angle is bisected. Again, that's just one of the theorems. So that means that this angle here must be 30. So I'm going to write that 30 degrees. This angle is obviously 90 because the diagonals are perpendicular. And through the triangle sum theorem, this angle must be 60. So what we're doing is, let me move this over a little bit. We're using those special triangles. So remember, opposite 30, that would be W, and this side would be W root 3, and this side would be 2W. Make a little divider there. So if we know that the side opposite 60, let me write the angles there. The side opposite 60 is 8 root 3. So that means W must be 8. So this side must be 8. And that means that M is equal to 2 times 8, which is 16. So now we have, we know what all these triangles are, or we know what the top triangles are. So this side here is 8. That's this length here, but that diagonal is bisected, so y must be 8 also. So y is 8. So we're done with the top triangles. We've used what we need to use for the top triangles. Looks like we're going to move on to the bottom triangles. Now the top triangles are special triangles. The bottom triangles are not. So we're going to have to do some other things here. We're going to have to use a Pythagorean theorem. So I'm going to draw the bottom right triangle. And we have this side is x, and this angle is beta. And this side is 17. And we also know, we know this side because we found that. Remember, that was 8 using the special triangles. There's a lot going on here. That side is 8. I know this can be intimidating, but you're going to have to start getting this down. So we can use the, I guess we don't really need beta in that. We can use the Pythagorean theorem. So a squared plus b squared is equal to c squared. And we have 8 squared plus x squared is equal to 17 squared. We get 289. You can use a calculator for that if you want to. And we actually already did this calculation, so we don't, it doesn't look like we really have room to show all the steps of that. So I'm just going to skip forward, and we see that x is equal to 15. So we found x, and now I think all we have to do is find beta. I forgot to rectangle m, so m will be equal to 16. And we'll move this up. And, you know, I just realized that I think I put the beta in the wrong place. We can find that with a calculator, but we can't find it with we need to use a calculator for that. So let's just move beta there. And you can see the top triangles are 30, 60, 90, so beta would be 60. So I'm sorry about that if that confused you. Beta is 60 degrees. That's step 5. So we should have 1, 2, 3, 4, 5 variables, 5 rectangles, 1, 2, 3, 4, 5. So that was kind of a long problem. All right, so I'm going to leave that in the window. And it's important to understand that in the next problem, you have 45, 45, 90 triangles. Okay, so and this this kite seems kind of lopsided there, but my drawing skills aren't perfect. But just be aware, you're not going to use a 30, 60, 90. We're going to use a different one we haven't used today yet, 45, 45, 90. But if you have those theorems right in front of you, these theorems here, then you should be able to do that problem. So go ahead and try number 18, and when you come back, we'll do it together. All right, we're back. So I'm going to start off with the easy ones. So y has to be 12. Do you see why that is? Because this diagonal is bisected by the other diagonal. Now, let's see, what can we do here? So I'm going to pull out the bottom right triangle, which is an isosceles triangle. Both angles are 40, 45. And the reason I know both angles are 45, I know this theta is 45 because I use the triangle sum theorem. Again, the diagonals are perpendicular. So, in fact, we should probably do that first. So theta plus 45 plus 90 is equal to 180. And theta plus 135, 180. Therefore, theta is 45 degrees. And then on to step 3. So I'm pulling out the bottom right, and we know that that's 45 now. We know that that's a 90-degree angle. This is M. And if I draw that triangle, remember it's WW, W root 2. So don't be confused by all these M's and these W's everywhere. Now we know that one of the sides of this triangle is 12. Remember, we found that. Y is 12. So that means that this other side must be 12 also. And this side must be 12 root 2. So equals 12 root 2. Why? Because we know W is 12 by this relation, so therefore this side must be 12 root 2. And I just realized that's a really crappy hypotenuse I wrote there. All right, so M is equal to 12 root 2. On to step 4. What else do we have here? Oh yeah, x. X we can find pretty easily. That's going to be 12. And I just designed the problem that way. The reason it's 12 is because it's a 45, 45, 90, so this side is 12. Again, I know this stuff looks complicated, but it's not really that complicated if you have your theorems down. But it is a puzzle. It's definitely a puzzle that you have to solve. And L, we know that M is 12 root 2. So L, because this is a kite, L must be 12 root 2 also. Let's see, we want to find P now. In order to find P, we have to probably use the Pythagorean theorem. For these triangles, we could use the special triangles because they're both 45, 45, 90 triangles. But for these triangles, they're not 45, 45, 90 triangles. So I'm going to pull out the upper right triangle. And this side is 5. This side we found is 12. And we're looking for P. And we know it's a right triangle. We don't know the angles, though. So now I'm going to do an arrow up here. So we're going to use the Pythagorean theorem. A squared plus B squared is equal to C squared. So 5 squared plus 12 squared is equal to C squared. And I'm not really going to do the math on that. C is equal to 13 because we already did a problem just like that earlier. And whoops, instead of C I needed to plug in P. That's P squared, so P is equal to 13. And we should have 1, 2, 3, 4, 5, 6 variables. So 1, 2, 3, 4, 5, 6. So it looks like we're done. So if you got that one right, that's very good. That was kind of a challenge problem, but you should, don't complain too much. You should be able to do those problems, or at least give it a good attempt. So at this point, we're going on to trapezoids. Remember, those are quadrilaterals where there's one pair of parallel sides. So here's all the theorems for trapezoids, so go ahead and take a screenshot of those. First, there's the trapezoid non-base pair theorem. So this is a base pair. Whoops. This is a base pair here because those bases are next to this side here, which is a base. Remember, the bases are the parallel sides. And this is a base pair up here because those are angles next to the top base. But these are non-base pairs because they're not part of the same base. These non-base pairs are supplementary. And the reason for that is pretty obvious. I'm going to put the theorem up on the page. Remember transversals? You have two parallel lines and you have a transversal. These are supplementary. That's one of the theorems that we learned. So that's pretty obvious, given the definition of a trapezoid. All right, so now that we have that theorem, before we go on to the other theorems, let's go ahead and use this one in some of the problems. And again, you should have got a screenshot of all these theorems. And then we'll get one more screenshot of the last theorem. But the first theorem is what we're going to use for number 19. It says, find the unknowns in each trapezoid below. So these two angles, because these sides are parallel, you have a transversal through them, and consecutive interior angles are supplementary. So that means that theta plus 42 must be equal to 180. And so theta is equal to 138 degrees. So that was step 1. And step 2, same thing with the other side. You have two parallel lines and you have a transversal through them. So consecutive interior angles are supplementary. So 105 plus omega is equal to 180. Subtract 105 from both sides, and we get 75 degrees. So that one is pretty easy. Now we need to go to some of those other theorems. So we have the trapezoid congruent base angles theorem, this top one up here. If a trapezoid is isosceles, and these are isosceles theorems, by the way, we're going into now. If a trapezoid is isosceles, then the angles in each base pair are congruent. So this one's congruent to this one, because that's a base pair, and this one's congruent to this one. But the non-base pairs, they're not congruent, so these are not congruent. Remember, they're only supplementary. So we know that this is an isosceles trapezoid. How do we know that? Because I marked these little green tick marks there. That means it's isosceles. So because it's isosceles, that means that base pairs are congruent. So that means beta must be 70 degrees. And we also know that these two angles are supplementary, so alpha plus 70 has to be 180, which means that alpha is 110 degrees. Now remember, if we have an isosceles trapezoid, and by the way, this is true for any trapezoid, not just for isosceles, but this part is only true for isosceles. So now that we know that because this is an isosceles trapezoid, that means that these must be equal to. So if alpha is 110, then omega must be 110 also. And now for 21, we need to go to this theorem here, the trapezoid one pair of base angles theorem. If the angles in one base pair of a trapezoid are congruent, then the trapezoid is isosceles. So if you just know that these angles are congruent, that's all you need to know that the trapezoid is isosceles. Or if you were given these two angles, because they're base angles and because one pair of base angles are congruent, that proves that it's an isosceles trapezoid, meaning those legs are congruent. So that's what we're going to use in this problem. We see that a base pair, these two angles are congruent. So because those base angles are congruent, that alone proves that it's an isosceles trapezoid. Well, if it's an isosceles trapezoid, that means that 5x minus 6 is equal to 3x plus 1. And that allows us to find x. So we have 2x is equal to 7, and x is equal to 3.5. Now for theta, for any trapezoid, those angles are supplementary. So 71 plus theta is equal to 180. And subtract 71 from both sides, and we get 109 degrees. And don't worry, you're going to try some of these problems later, but for now we're just doing them together to get used to these theorems. So let's see here, that was it for that problem. Now 22, we're going to use the trapezoid diagonals theorem. If a trapezoid is isosceles, then its diagonals are congruent. Actually, we're going to need the converse of that one. So if the trapezoid is isosceles, the pink diagonals there are congruent. But the converse is true also. If those pink diagonals are congruent, then that proves that it's an isosceles trapezoid. So we see here that these orange diagonals are congruent because it tells us they're congruent. So that proves that it's an isosceles trapezoid. So that means 6y plus 7 must be equal to 3y plus 22. Do the math on that, and we end up with y is equal to 5. And it looks like that was it on that problem. So now it's time for you to try. I'm going to give you another opportunity to take screenshots of these. You can't do much unless you have these theorems. And I'm going to go ahead and try to leave all these in the window Hopefully that's not too small, number 23. But go ahead and try number 23. When you come back, we'll do it together. All right, we're back. So this is an isosceles trapezoid. How do I know that? Because these sides have that pink tick mark. The legs are congruent. So one of our theorems tells us that if the trapezoid is isosceles, that means base angles are congruent. So 2w minus 3 and 4w minus 53, those are base angles. So do the math, and we get w is equal to 25. Now, for any trapezoid, the non-base pairs are supplementary. So we know that alpha plus 25 is 180. Wait, I'm sorry, I didn't do that right. Alpha plus, we got to plug in 25 to get the actual angle, is equal to 180. So we have alpha plus 47, if you do all the math on that, is equal to 180. And subtract 47 from both sides, and we get 133, it looks like. So, looks like that's it for that one. So if you got that answer, good job. That was kind of a challenging one to start out with, but if you got stuck, that's okay, but now you know how to do that particular problem. Now on 24, go ahead and try number 24. When you come back, we'll do it together. All right, we're back. These are non-base pairs, so they're supplementary. So alpha plus 90 must be equal to 180. And just subtract 90 from both sides, and we get alpha is equal to 90. So if you got that answer, good job. And the other angles, these two are non-base pairs, so they're supplementary. So 2w plus w plus 30 must be equal to 180. 2w plus w is 3w. And subtract 30, divide by 3, we get 50. So w is equal to 50. I just skipped ahead there because we're running out of room. So if you got that answer, good job. All right, on to 25. This is the theorem where you're going to have to use, if one base angle pair is congruent, then that proves that it's an isosceles trapezoid. So try 25, and when you come back, we'll do it together. All right, we're back. So these base angles are congruent, so that proves that this is an isosceles trapezoid, which means that 99 must be equal to 3x. Therefore, x is equal to 33. And we know that base angles must be congruent in an isosceles trapezoid because we've already proven, because these angles are congruent, we've proven that it's isosceles. So we now know it's isosceles. But another theorem tells us, the first theorem we learned tells us that those base angles are congruent. So theta must be 60. The first isosceles trapezoid theorem we learned, that is. We learned other theorems before that. So step 3. Actually, there is no step 3. We just have x and theta. So if you got those answers, good job. Again, if you're having trouble with this, it's probably because you don't have the theorems right in front of you. Or if it is possible to get stuck with this, so don't feel bad if you get stuck, but you have to get an honest attempt. So try number 26. If we know the diagonals are congruent, then that means that it's an isosceles triangle. So try 26. When you come back, we'll do it together. All right, we're back. So 4x plus 1 is equal to 3x plus 5 because the diagonals are congruent. It's isosceles. Because it's isosceles, that means those sides must be congruent because that's just the definition of isosceles. So x is equal to 4. So if you got x is equal to 4, good job. Now we have to learn something called the trapezoid midsegment theorem, but we can't learn that theorem unless we first learn what a midsegment is. This tells us what a midsegment is. A midsegment is a segment that connects the midpoints of the legs of a trapezoid. So this red segment here is the midsegment. It's just a segment. That's all it is. Now I know that this is the midpoint of the leg AB because we see that these two sides are congruent. The midpoint divides the segment into two congruent segments, and same thing with the other side. So that's the midsegment. It's just a segment that goes through the middle of the trapezoid. Now the midsegment theorem tells us that the midsegment is parallel to the other to the two bases. So this midsegment is parallel to these two bases. That's part 1 of this theorem. That's right here. And part 2 says that the length of the midsegment is the sum of the two bases divided by 2. You can also say it's the average of the lengths of the bases. So that's what this tells us. So again, to find this length, you add this side plus this side and divide by 2, and that gives you this length. So we know that the sum of the bases, sum of the base lengths, divided by 2 must be equal to the length of the midsegment, which we're told is 2x minus 4. So we're just going to add these up. 16 plus 20 is 36. And 36 divided by 2 is 18. You didn't really have to show this intermediate step. You probably could have just gone straight to 18. And do all the math on that, and we get x is equal to 11. So that was a problem where we use the midsegment theorem, and we'll try another one of those together before you try one on your own. So we have a midsegment. This pink line is a midsegment, and the theorem. Remember, the theorem has two parts. So one of the parts tells us that this information that we just did here to find the length of the midsegment. But the other part tells us that the midsegment is parallel to the two bases. So this line is parallel to these two, or that segment is parallel. So if it's parallel, that means that these two angles are supplementary, and these two angles are supplementary. Now, because this is a trapezoid, obviously this angle and this angle are supplementary. We already learned that. But because this line segment is parallel, that means that the same applies for these angles. They're supplementary also. Because we're not just dealing with two parallel lines, we're dealing with 3 parallel lines. So we can consider each pair separately. So first I'm just going to do the normal stuff. So beta plus 102 is equal to 180. That's just the same thing we did before if you just ignore the pink segment there. So subtract 102 and we get 78. So beta is 78 degrees. So that was easy. And what else can we do here? So at this point we actually don't need to use, supplementary stuff, because now we know that if you consider these two segments by the corresponding angles postulate, this angle must be congruent to this angle. So that's just one way to do it. There's a lot of different ways to do it. So theta must be 78 degrees because they're both upper right in that area. Again, if you draw these and the transversal, these angles are both in the upper right. That's not the same situation with 102. 102 is not in the upper right, it's in the bottom right if you extend that transversal out like so. So those are supplement. Theta and 102 are supplementary. They're not congruent. All right. Let's see. So part 3. So same situation for omega and alpha. Omega must be 90 degrees because of the corresponding angles postulate, because we have a 90-degree angle down here. And then we know that alpha and omega are supplementary. And we know that omega is 90, so we just figured that out. So obviously alpha is 90 also. 90 degrees. And by the way, I didn't mention something. The reason we know this is a midsegment is because this segment is congruent to this segment because of those green tick marks. And we have 7 centimeters and 7 centimeters. So that proves that it's a midsegment. I didn't mention that over here either. You have to see those marks or else it's not a midsegment to begin with, so you can't use these theorems. So we're going to do one more of these before you try one on your own. Now I know, again, this is a midsegment, this red line here, because it divides the legs in two equal parts. So I can use the midsegment theorem. So we know that the sum of the bases, so 8 plus 4x plus 2, divided by 2 is equal to 10. So I added up the bases, 8 and 4x plus 2 are the bases, divided by 2, and we know it must be equal to the length of the midsegment, 10. Now, students might have a little trouble with this, so I'm going to show every step here. So I'm going to rewrite this, 8 plus 4x plus 2 over 2 is equal to 10. So we want to get rid of the fraction. So this is divided by 2, so we have to do the opposite of division, so that means multiplication. So I'm going to multiply both sides by 2, and we get 20 is equal to 8 plus 4x plus 2. Then we can add those up to get 10 plus 4x is equal to 20. Do all the math on that, and we get x is equal to 5/2. So that one was a little bit more involved. And we don't have to put the units. I'm not going to make you because there's operations on it. All right, so now it's time for you to try. Go ahead and try number 30. Remember, the two parts of that theorem are that if you have a midsegment through a trapezoid, then the midsegment is parallel to the two bases, which means a lot of other theorems apply. And also the length of the midsegment is the sum of the bases divided by 2. So go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. We see we have a midsegment because we have these two and these two segments. The pairs are equal. So we want to find y, so we know the length of the midsegment. And I'm just switching the formula around from the last time I did it, but I'll put it on the right side this time. So 30 plus 8, the sum of the bases divided by 2 is equal to y. So all we have to do is just simplify that, and we have y. So we get 38 over 2, which is 19. And we can put units because there's no operations on that. So what else do we need? We need theta. Omega is really easy. I'm just going to do that over here. Omega is just going to be 65. Now, why is that? Well, that's the corresponding angles postulate. We have the bottom right angle, and we have the bottom right angle are the same because they're both bottom right, so omega is 65. And step 3, theta is now going to be, those are consecutive interior angles, so theta plus 65 is equal to 180. And again, this only works because the midsegment is parallel with the other two bases. So theta equals 115 degrees. So if you got those answers, good job. Let's see, we have 3 variables. We got that right. So try 31. And this one's just going to be based on the idea that the midsegment is parallel to the other bases. When you come back, we'll do it together. All right, we're back. This is bottom right, this is bottom right. So theta is just going to be 110. Again, that's based on the transversal postulates. Now these two are consecutive interior angles, so that's the first theorem we learned for trapezoids. I think it was the first theorem. So theta plus 48 is equal to 180. Therefore, omega, did I say theta? I meant omega plus 48, and that would be 132 degrees. And what else do we have? I guess that's it. So if you got that, if you got those answers, good job. All right, try number 32, and when you come back, we'll do it together. 32 is going to require a little bit more algebra. All right, so we know that the sum of the bases divided by 2 is equal to the length of the midsegment. And we want to get rid of that fraction. There's a number of different ways to do this, but I just like getting rid of the fraction first. B plus 32 is equal to 52. I hesitate to show you this method, to be honest with you, because it can be kind of misleading when you're doing other algebra problems. Subtract 32 from both sides, and we get B is equal to 20. So if you got 20, good job. Whoops, got to put that unit because there's no operations on it, so I put the units when there's no operations. People may disagree with me on that, but it's not really that important. So B equals 20. If you got that answer, good job. So now we're done with trapezoids. And we're going on to rectangles and squares. So this is going to be probably pretty quick, hopefully, because rectangles and squares are pretty easy. So we have the first of all, take a screenshot of these two, or just this one page, I guess. So rectangles are parallelograms. That's the first theorem. Rectangle diagonals are congruent, as you might expect. The green ones are congruent. Because a rectangle is a parallelogram, obviously opposite sides are congruent. That's one of our parallelogram theorems. We haven't used that one today, but that's important. And then we have the rectangle diagonal bisection theorem. Obviously, if a rectangle is a parallelogram, then diagonals bisect, because that's one of the parallelogram theorems. And so now we're going to do some practice problems. So again, you should have gotten screenshots of all that. So we have a rectangle here. It says find the unknowns. So we know opposite sides are congruent. That's one of the theorems that we just looked at. And you know, a rectangle is a parallelogram. So obviously opposite sides are congruent. So y is 4. And this side is congruent to this side. Add 2x to both sides, subtract 4 from both sides, x is equal to 4, x is equal to 1. And what else do we have? Z, we need to find z. Now we can find z using the Pythagorean theorem. Because if you draw z, you see we have a right triangle here. Now you might be thinking, wait a second, how do we know that this is a right angle? Well, that's the definition of a rectangle, remember? We know that's a right angle. So, just wait for my computer there. So first we have to find the sides. We know that this side is 8, but we haven't found the other side yet, so we have to plug in 1 to x. So we get negative 2 times 1 plus 8 which is equal to 6. So this side is 6. It's not exactly proportional, but who really cares? So now we're going to draw that diagonal, and we see we have a triangle where one side is 8 and one side is 6, and it's a right triangle. So we can just use the Pythagorean theorem. So we're at a room, which happens very frequently. You have to know what to do, so we just go up, and we have a squared plus b squared is equal to c squared. Now, if you recognize this Pythagorean triplet, you know what the answer is going to be. If you don't know what Pythagorean triplets are, you can just go online, and you can see there's a few triangles that are Pythagorean triplets where you can, if you memorize them, you don't really have to do the Pythagorean theorem. You can just write the answer. And we get 100 is equal to z squared, and z is equal to plus or minus 10, but it must be a positive 10. I'm just going to skip forward here. We don't have time to show every step of that. So z is equal to 10. And there you go. All right, let's do one more of these before you try one on your own. There's not really a lot we have to do on rectangles because they're fairly easy. But diagonals of rectangles are congruent. And we also know because they're parallelograms, because rectangles are parallelograms, the diagonals bisect each other. So that means that all these lengths, this length, this length, this length, and this length, they're all congruent, as you might expect. So we know that that x is equal to 52 inches. And we know that 52 must be equal to y plus 10 also, which means that y is equal to 42. So pretty easy on that one. So now it's time for you to try. Go ahead and try number 35, and when you come back, we'll do it together. All right, we're back. So step 1, opposite sides of rectangles are congruent because a rectangle is a parallelogram. So do the math on that, and we get x is equal to 2. If you got that answer, good job. And we also know that negative 2 plus y is equal to 12. Again, opposite sides are congruent, so y is equal to 14. If you got that answer, good job. And now we have to use a triangle. So I'm going to draw the triangle we're using. And this side is A, and this side is 12, but we have to do some calculations to find the other side. So 2 times, what was x? 2 times 2 plus 1 is 5. So that side is 5. I'm not going to write the 5 because that might kind of confuse people. So 5 and 12, I'll just write an equals like that. That's kind of non-standard, but ran out of room. So a squared plus b squared, and you know what? That's a different variable. I'm sorry. So I need to change that to, let's see, I'll just change that to m. You can't have a different definition for the same variable. A squared plus b squared is equal to c squared. I don't want to confuse you with that. So 12 squared plus 5 squared is equal to c squared. And we don't really have time, so I'm just going to simplify it. C is 13. Whoops. I got to plug in m there. Sorry about that. So m is 13. So if you got those answers, good job. So you should have a equals m. I changed the variable there. Sorry about that. All right, so diagonals bisect, and diagonals are congruent. Try 36. When you come back, we'll do it together. All right, we're back. Let's see here. So y must be 19, and 19 must be equal to 2x minus 3. do the math on that, and you get x is equal to 11. So if you got that answer, or both those answers, good job. Now we're going on to squares, the last part of the class today, so go ahead and take a screenshot of those. Again, squares are not going to be that difficult. So there's a square parallelogram theorem. As you might imagine, a square is a parallelogram. Square rhombus theorem, if a quadrilateral is a square, then it's a rhombus. We already learned that. If a quadrilateral is a square, then it's a rectangle, by the definition of a rectangle. We already learned that pretty much. But this one we haven't learned, the square two special triangles theorem. This theorem says that if you draw the diagonal of a square, then you make two special triangles, and they're both 45, 45, 90 triangles, which means that this relation, which we learned in a previous class, works. So that's kind of useful. And then there's the square four special triangles theorem. That means if you draw both diagonals of a square, not just one, but both diagonals, then you have four 45, 45, 90 triangles. Again, these are very useful theorems. So get that screenshot, and we're going to start with number 37. I think we only have about 4 problems left, so you're almost done. Well, you're not done, but I'm done. You got to do the homework. But maybe you want to have a lunch break before your homework. So find the unknowns in each square below. So we know that the sides are congruent, but all the variables are different in each side. So we can't really use an equation with that. But we do know that the diagonal is 8 root 2. So I'm going to pull this out, and we have 8 root 2, and then y, and then x minus 1, and we know that this is a 90 degree, and we know that this is 45 and 45 based on the one of those theorems. We created two right triangles that are both 45, 45, 90 triangles. So what that means is, again, we're going to use that relation. Both legs are supposed to be the same length here. All right, so that relation tells us omega, or WW and then W root 2. Remember that? That's for 45, 45, 90 triangles. It only works for 45, 45, 90 triangles. So we know this side is 8 root 2, so that means W is 8. So that means that Y has to be 8. And we also know that X minus 2 has to be 8. So that means that X has to be 9. And 18A must be 9, or excuse me, it must be omega is 8, y is 8, so that must be 8. So divide both sides by 18, and we get A is equal to 8 over 18, which simplifies to 4 over 9. So A is 4 over 9. And alpha, kind of ran out of room here, sorry about that. Alpha is 45, just because we know, based on the theorem, you create a diagonal, 45 degree angles. And that's 1, 2, 3, 4, 5. 1, 2, 3, 4. We're missing something here. Z, I didn't find Z yet. So Z plus 7 has to be equal to 8, because remember I found Y is equal to 8. So all the sides are equal to 8, so that means Z must be equal to 1. All right. So now I'm going to do one more of these before you try some of these on your own. Again, these are kind of obvious problems. They're not too difficult. So now we're creating, in this problem we created 2 right triangles, but in this problem we're creating 4 right triangles. So if these are all right triangles, we know that that's 90, obviously. I mean, it has to be 90 if they're right triangles. Theta is 90 degrees. So I'm going to use the left triangle, and we know that this has to be 90, obviously. and this side is 3. So what we're going to do is use the WWW root 2 theorem. So you have 45, 45, 90. So if that we know W is 3. So that means that this side must be 3 root 2. W root 2, 3 root 2. So that means all the sides are 3 root 2, but that means that A up there has to be 3 root 2 because that's the length of the sides. And B, again, all these triangles, all these 4 triangles are the same, so B is one of the legs. So B is obviously going to be 3, just like this length here. So if you know that those are 4 right triangles that are 45, 45, 90, then this stuff is really not that difficult. So we should have 3 answers, and we do. All right, so now it's time for you to try. You can take screenshots of that stuff if you need to use that work. And we have, looks like 2 more problems, I believe. Actually, no, we have to do one more together. Sorry, I got your hopes up there. So this is a parallelogram, so that means diagonals bisect. And first of all, let's do the easy part. 2b must be equal to 45. So b is equal to 22.5. You can use your calculator for that if you need to. Let's see here. Diagonals bisect, so 5x plus 2 is equal to negative 2x plus 16. And we have 7x and 14, so x is equal to 2. And I'm going to use the top triangle there. I'm going to pull that one out. So we have y. And we know it's a 45, 45, 90 based on the theorem. So we just have to find this side. We can find that side. We have to use negative 2x plus 16. So negative 2x, we found x is 2. So then we have 12. So this side is 12. That means this side is 12 also. And that means that y must be 12 root 2. Now why is that? Because again, that theorem, W root 2 in a 45, 45, 90. So y must be W root 2, W is 12. So y is equal to 12 root 2. And I think that's it for that one. All right, so now it's time for you to try. 3 more problems, it looks like. Sorry, I didn't realize we had 3 more. So go ahead and try number 40. And again, these when you draw the diagonal, you create 2 45, 45, 90 triangles. You need to use WWW root 2. And when you draw 2 diagonals, you make 4 congruent right triangles. And again, you have to use WWW root 2. All right, so try number 40. I'm going to leave this one in the window here. And when you come back, we'll do it together. All right, we're back. Let's see here. We know this side is 10. Because these are squares, all the other sides must be 10 also. So 10 is equal to y. And 10 is also equal to negative a plus 10. So we subtract 10 from both sides, and we get 0 is equal to negative a. Divide both sides by negative 1, and we get a is equal to 0. And I know that's kind of strange, but it's just negative 1 times a. So divide by both sides by negative 1, and a is 0. So you might think, hey, you can't do that. A length can't be 0. Well, a is not the length. A is just a number inside this expression. The actual length is 10. And then we also know that 10 is equal to negative 2 plus 6b. Do the algebra on that, and we get b is equal to 2. And on to step 4, alpha, we know that's 45, just based on the theorem, 45 degrees. And what else do we know? x has to be whatever the side is times root 2. Again, you can just pull out the triangle. We have x, and then we have 10, 10. So we're using the w root 2. That side's supposed to be equal to that other side. So x is just 10 root 2. So if you got 10 root 2, good job. If you got all those answers, good job. 1, 2, 3, 4, 5. We should have 5 answers. 1, 2, 3, 4, 5. All right. On to number 41. I'm going to leave those in the window. Try 41, and when you come back, we'll do it together. All right, we're back. This side is 5 root 2. So that means that these, and when you draw 4 triangles, the actual sides of the sides of these squares are going to be the hypotenuses of the triangles. So first of all, beta. Let's do the easy one first. We know beta has to be 45 degrees. And another easy one is b. We know b has to be 5 root 2, right? Because it's a square. All the sides are the same. And now we're going to pull out one of those triangles. I'll pull out the right one. So we have y, and then we have 5 root 2. But that's a 45, 45, 90. And if you pull out, if you write your w root 2, 45, 45, blah, blah, blah. So that means that if this side is 5 root 2, then the other side would just be w, which is y, which is just 5. So y is 5, and the diagonals bisect each other because a square is a parallelogram. So x is equal to 5 also. So if you got those answers, good job. Try number 42. It looks like this is going to be the last one for today. I'm proud of you if you've gotten this far. So try number 42. I'll keep those in the window, and when you come back, we'll do it together. All right, we're back. So we know that the diagonals bisect each other. So that means b minus 1 is equal to negative b plus 8. And the reason we know the diagonals bisect each other is because a square is a parallelogram. And diagonal bisection is just one of the principles of parallelograms. So now we just solve that, and we get 3b is equal to 9. Divide both sides, blah, blah, blah. We get 3. So b is 3. Now we have to actually find some of the sides of those triangles. So we need to plug them back in. I'm going to draw. So that's x, and b minus 1 is going to be 3 minus 1. So I guess I'll just draw another one just to show the steps here. So that's x, and then 3 minus 1 is 2. So that side must be 2 also, because again, it's a 45, 45, 90. And then, sorry about that crappy triangle there. So then we have to use w root 2. And so obviously x would have to be whatever w is, which is 2 times root 2. All right. What else do we need? So we need alpha. We have 5 times alpha. But we know that's going to be a 45, that's going to be a 90 degree angle. So 5 alpha is a 90 degree, because again, all these are 45, 45, 90s, and we can tell if it's a 45 or a 90, but just by looking at it. So divide by 5, and we get 18. So alpha is 18. And you can put degrees or not, but since that was an operation, I'm not going to make you. So if you got that answer, all those answers, good job. So that was the class today. If you want to take screenshots of all the work we did, go ahead and do that now. So this is screenshot 1. Screenshot 2. Screenshot 3. Screenshot 4. Screenshot 5. Screenshot 6. Screenshot 7. Screenshot 8. Screenshot 9. Screenshot 10. Screenshot 11. And number 12. And number 13. And screenshot 14. And screenshot 15. So don't go before you get your homework. Here's the homework. We have screenshot 1, screenshot 2. Remember, if you don't do the homework completely and correctly, neatly, and put it in your binder, it's an absolute guarantee you're going to learn nothing in this class. Screenshot 3. So get that homework done completely correctly and neatly, and make it organized in your binder in the proper order, and I'll look forward to seeing you in the next class.